Alright, here's our last video for lesson 5.3 for this week, I guess, of explorations. This is exploration 533, an advanced qualitative look at rates. If this looks familiar to you compared to the stuff we did in Unit 1, with kind of drawing those graphs and rates of change and distance over time and all that, very close to that right now. And what we're doing is we're talking about acceleration, velocity, and position versus time. I swear this isn't physics. Well, I guess it is a little bit of physics, but don't worry too much over it. The important thing to remember here is that we are talking about rate of change. Recall that velocity is the rate of change of position, and acceleration is the rate of change of velocity. In other words, the slope of position is velocity. And same thing going even deeper, the slope of velocity is acceleration. Ooh, that just did not work out right there. I can usually ignore some bad handwriting, but that was awful. I apologize. Anyways, is acceleration. Acceleration. There we go. And this is going to be the focus of this particular exploration. For each of the following velocity versus time graphs, try to sketch what you think the corresponding acceleration time graph will look like. Be prepared to present and justify your results. So basically, what they're asking is, given all these graphs, what would the graph of the slope look like? Well, let's see. Take a look at number 1. And again, these are all velocity versus time. And here we have a constant velocity. Well, if something's got a constant velocity, it's not exactly accelerating. The velocities stay in the same number. And if we're to talk about this in relationship to slope, well, what's the slope of that line right there? The slope of a horizontal line is 0. So our acceleration is actually equal to 0. So what would that graph look like? If I were to sketch another graph, and I'm going to draw it really tiny over here, and this is t, and this is a. If I were to draw a graph of the acceleration, well, the acceleration is constant 0. It's not changing. So what does the graph of 0 look like? Well, it's just something that kind of just stays on that axis. That would be a graph of the acceleration. It's just a horizontal line at 0. Same thing over here. We have, this time, we have t, and we have our velocity. This time, notice that your slope is a constant number. Your velocity is increasing, but it's increasing at a constant rate. Well, in this case, I don't know what our exact slope is, but I can tell you that it is some positive number, and also that it's a constant. Oh my gosh, my handwriting is getting worse throughout the day. I apologize. This is my 3rd video today, and like my 3rd video in 3 years. So, constant. There we go. We have a constant acceleration, a constant slope. So how do you graph a constant number? So again, I'm going to draw my axes with t and with a. And this time, our graph is a constant positive number. What does the graph of a constant positive number look like? Well, it's going to look something like this. Just a straight horizontal line, a straight positive line. But yeah, that's what this exploration is about. I'll let you do 3, 4, and 5 on your own. I don't think you need me going through those with you. Number 6 is always kind of a fun one because we have several different slopes happening on this curved line right here. And in order to understand what's happening, let's kind of break down what's happening. At the beginning, we have something that looks like a slope of 0 right here. And then as we go through, if I were to draw a bunch of little lines right here to kind of represent each of those slopes, we have all these positive slopes that are increasing, and one slope that is a huge, huge positive number, and then our slopes are still positive, but they're going back to 0. We start off with something that's close to a 0 slope. We're ending with something that's a 0 slope. And somewhere in between here, we have something that is headed towards positive infinity here. Doesn't like me. There we go. We have some huge positive number happening right here. But notice again that all of these slopes that are here are positive. So how do I draw a graph with a bunch of positive numbers? And in right here, it looks like it's going towards infinity, but it starts at 0 and ends at 0. Well, let's see. I'm going to go ahead and draw my axes. This is t. This is our acceleration. And then I have something that starts at 0 and then goes off towards infinity, almost like an asymptote, and it could be, and then comes back to 0. And again, notice all these numbers are positive. We have positive slopes this entire time. No negative numbers happening here. Everything's a positive acceleration on here. And we have this in between. There's some people that may draw this a little bit differently. Maybe you feel that that is a hard number, because how do you exactly draw infinity on a graph? Is it possible for this to have an infinite slope? That's something to discuss with your calculus teacher. But as for right now, I think this is a pretty good slope. Or even if you had drawn something like that, that would have worked as well. Some huge positive number up here. And then the challenge is also kind of fun. Don't think of it too much as a challenge. But this is kind of going backwards if you were to do this. Given these velocity graphs, how would you draw the position graph? So you would think of each of these graphs given here as your slopes. How would you go backwards to do that? And I'll do a quick one with you. I'll draw number 1 as part of the challenge. If we have our velocity versus time graph, what would the position versus time graph look like? Well, right here, this is a constant positive number, so we want to draw something with a constant positive slope. So, something like that. That would be your answer for the challenge for number 1 right here. But that's our last exploration. You should definitely get to some of the practice problems that I've sent out, as well as the Canvas quiz eventually, and then we'll have a concept check over this.